Hello everyone, welcome to GDC classes. So we are back with our sixth video of the 100-day Biopharmaceutics challenge, whereby we will be covering the Michaelis-Menten equation. So for the Michaelis-Menten equation, we will have to see few consideration. Number one, it is going to explain the enzyme kinetics. So when we are talking about the enzyme kinetics, we definitely know that enzyme is going to form the complex with the drug or the substrate. Now, because the enzymes are actually limited, initially when we say the drug concentration is low, we say the enzymes are still available, so it tends to follow the zero order kinetics. But as soon as the drug concentration increases, it starts to saturate the enzyme. Because of the capacity limited, they are going to be all occupied, whereby the non-linearity condition arises. Now from the first order kinetics which it was initially following, now it turns to the zero order kinetics. That is why we call it as a capacity limited mixed order kinetics. So Michaelis-Menten equation actually gives you certain assumptions which I am just going to tell you. Number one, we have seen that it is going to allow us to explain the enzyme kinetics. Now it is going to justify this non-linearity condition. You already know why this non-linearity condition is there. Third, because it is a capacity limited process, it is going to have the saturation at a certain point. Fifth, I have told you that it is going to follow the mixed order kinetics. Why mixed order? Because initially when the drug concentration is low, then still the enzymes are available. It is going to follow first order initially. Then because the saturation phase will come, it will follow the zero order kinetics. If you want to plot it in a graph, it will look certainly like this. So initially at a point, this is going to be, there are two parameters also that you must know. One will be your Vmax, one will be your Km, right? So Vmax will be this maximum rate. Vmax is going to be this maximum rate, and Km will be going to be that drug or the substrate concentration at half the maximum. That means we can certainly say it is going to be somewhat this. Okay, that this can be represented somewhat to this, that will be equal to half the maximum. So initially what was happening, initially you can see it was following first order kinetics till a point. Here you can see this will be Vmax upon 2, that is going to correspond to our Km only. Then after that the saturation phases start, whereby we can say it is now following the mixed order kinetics, right? We already know because the enzyme is going to form complex with the substrate, forming the enzyme substrate complex, which is now turning into enzyme and the product. So we have an equation, basically Michaelis-Menten equation will be minus dC upon dt Km into substrate concentration, it will be Vmax into substrate concentration upon Km plus substrate concentration. This is going to be the equation for the Michaelis-Menten equation that explains the non-linearity only. So now there are certain conditions where we can put this, where from the what question can be asked. Suppose when Km will be equal to the substrate concentration. Suppose first condition when Km is equal to the substrate concentration. Now what will be this minus dt by dt? It will be equal to Vmax upon 2, right? This will be the equation will turn somewhat like this. In the second state, whereby we can say Km, if it is more than the substrate concentration, now what is going to happen? It will be minus dt dC upon dt. It will be equal to your Vmax into substrate concentration upon Km. Because now Km, we can assume Km plus S will be somewhat equal to Km only, because the Km is more than the substrate concentration. So the equation will turn somewhat like this. In the third scenario, I am writing the third scenario here, whereby the Km will be less than the substrate concentration, whereby the Km will be less than the substrate concentration. So minus dt by dt will be equal to Vmax. which is the maximum reaction rate. So when this explains that a high concentration of substrate or drug, your reaction rate will be Vmax. Okay, very important. You can already see from the equations. So this equation turns out to be explaining your non-linearity. So for studying the Michaelis-Menten equation, we have to see certain points. We'll just quickly see those. Okay, so this is the graph which we have already seen. You can see initially it was the first order, and then at a Vmax was the maximum reaction rate, and half the Vmax was your Km. So you have enzyme substrate and the enzyme substrate complex. You have the Vmax, you have the Km values with you, right? So we were saying that enzyme is going to form the complex with the substrate, then forming the product. So at a low drug concentration, it was going to follow the first order kinetics, right? At a higher concentration of drug, it is going to form the complex at a maximum reaction rate, which was Vmax. Now that will be referred to as the zero order, following the non-linearity in mixed order. Now this Km, this Vmax, half the Vmax at which the drug concentration will be equal to your Km. Now this equations, based on the equations, we have seen the linearity and non-linearity. Generally it was non-linear. To explain how we can turn into linear, there is a plot which we call it as Lineweaver-Burke equation. This equation actually just we have done the reciprocal of the Michaelis-Menten equation. Okay, and then plot the graphs for the reciprocal plots of the reaction rates as well as the substrate concentration. So this is all about the Michaelis-Menten equation. This is the important graph whereby initially and then the zero order kinetics, which we can already see. Okay, then I think this is okay. Then the concept of inhibitors, that I will cover in the next part. For as of now, for takeaway points will be, yes, it will be a non-linear kinetic, enzyme kinetics, capacity limited, mixed order kinetics. All the terms should be clear. At a high drug concentration, it will turn into a saturable condition whereby all the sites of the enzyme will be occupied. We have an equation which we can justify using the substrate concentration and how the values of Vmax and Km are going to change. Okay, then followed by we will be covering the competitive, non-competitive. In the presence of inhibitors, what will be the reaction that will be achieved and what will be the plots that we will get. Okay, thank you so much. We will meet in the next session.